Hi, Steve Ladd here again with my next installment on building the proa sailboat. And this is like the end of fall, so I won't be able to do any more this season. I'm going to explain to you now what I've done during this season. First is the deck. Now, this is really the beginning of the deck, but you see that there are these divinyl panels cut in place. Some of them are big, like this and this. And some of these divinyl foam panels are smaller to fit around these hatch openings. And then up there at the bow, you can probably make out some more big divinyl panels up there. Those have yet to be glassed and bonded in place. Next, I want to show the gudgeon mount. The gudgeon is a hole here through which this pin fits. This is called the pintle, and there's a hole in here that this pintle goes into. Of course, there's one down there as well. And then the key is to make the gudgeon strong enough, having a strong enough attachment to the boat. And that's what this overall structure is here. It's a 1/8-inch thick stainless steel set of plates bolted together, welded together, and then that whole thing bolted to the stern of the boat. And I'm going to take this panel off so as to show you the reinforcements on the inside that will make the boat strong enough to receive these forces. There's board. I explained this at the last video. Board reinforcements here, 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 and here. Bolts coming in, and then some of these bolts are also those of the handles. So the handles are really part of this structure. Here's one of the handles. Okay, so I'm going to put this back. Now I'm going to explain the steering gear. This is part of the steering gear. Now, the purpose of the steering gear is to move the tiller from where it would normally be back here to where it's more handy to the helmsman, which is up here in the cockpit. And in moving the tiller up to there, you also get around the problem of the mizzen mast here, which would otherwise be in the way. So I'm going to show you what the components are of this steering gear. And by the way, this is all just provisional steering gear, not the final thing. There is the the rudder post. And by the way, this is what's called the fork. This is not the actual rudder. The rudder hangs down from there. But this is the rudder stock. To the rudder stock is attached a yoke. To the yoke is attached two steering lines. Then the matching yoke up here. This yoke is attached to a tiller stock, which is analogous to the rudder stock. They both rotate vertically. And this one rotates vertically inside a tube, and you can see the tube here. This is the tube within which the tiller stock rotates. The tube itself is like a socket. It's a mast step, you might say. It's stepped down on the keel, so that's quite strong. And then the final component of this setup, of course, is the tiller itself. Now, this is all intended to be strong enough to use on a few preliminary sea trials as I determine whether the geometry and so forth is more or less correct, at which point I will make these things out of more final strong materials like stainless steel. Now, the final thing I want to explain is the Oct mounts. The Oct mounts are the main thing I've been working on for the past year. My last installment to you was in February, and at that time I showed you a big roll of plans where I had planned what these Oct mounts would look like, how they would be. Well, I threw away those plans. I did not do it that way. I don't have to show you any more plans. I can show you the actual thing because it's pretty well finished yet. So I'm going to show you actually on the actual boat. First I'm going to show you this model. This model represents the boat. This is the main hull. This is the AMA or outrigger. And these are the cross beams or ACAs. I use the word ACA. So the ACA mounts are the places where the ACA attaches to the main hull. There's the forward port mount, the forward starboard mount, port aft mount, and aft starboard mount. We are now standing at the aft starboard mount. So the main component, the most important, is what I call the mount plate. This is a plate made out of plywood and fiberglass. And this plate will get bonded and bolted to the upper plank. This is called the upper plank. Now it isn't bonded and bolted yet because it'll be more convenient to put on the deck first, then put that on. But when that does happen, that will be a permanent attachment. It will never come off again. The mount plate has this gap in it here, and this is for the ACA to fit into. The ACA is square in cross section. It sits in here. Then there's a lashing that goes around it and goes around these, what I call spools. Wrap, 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 ties it off. That happens on all four of the ACA mounts, and that allows for quick assembly and disassembly of the boat. Now, how are these forces of the ACAs being distributed out into the boat? You can't just have the ACAs up, the forces and the stresses all in one place. You have to bleed off into the hull. Well, to show you that, I need to take off a couple of components here of what's going on the deck, and I'm going to show you some reinforcements to the interior. Now, the panels that are in the vicinity of the ACA mounts consist of the upper plank, the diagonal plank, so-called, but it goes down a diagonal, and the bulkhead. There are Cusa board reinforcements or panels on each of those surfaces. This is one, so here's an example of what I'm talking about. This is Cusa board, and it's faced with a fair amount of fiberglass. So let's come closer, and I'll show you the, I'm going to get a flashlight, show you the surfaces that have these reinforcements. Here's the Cusa board reinforcement to the upper plank. The bolts aren't in place yet because it's bonded in place, but it's not yet bolted. It will get bolted when the mount plate is attached. Here is the Cusa board reinforcement to the diagonal plank. It is bonded and bolted in place. Here is the Cusa board reinforcement of the bulkhead, bonded and bolted in place. And now on the other side of the bulkhead, finally, there's another Cusa board reinforcement to the upper plank, but on the forward side of the bulkhead. Now, that has strengthened the panels, but we also need to strengthen the attachments between the panels. All these panels are already attached to each other, of course, by such things as fillets. Here's a fillet, here's a fillet. But in the vicinity of the ACA mount, I felt the need to reinforce the attachments between the panels, and so I will now explain those. First I will show you this one. This is a pointer? This is, if you've heard of angle irons, this is not an angle iron, but it's an angle that I created, custom made to fit the angle in question. And it is bolted to the, bonded and bolted to the diagonal plank and the upper plank. So this is a reinforcement of the joint between the diagonal plank and the upper plank. These bolts, as again, are not in place yet. And next is a pair of aluminum angles. Here again, the angles are custom fitted to the geometry of it. This one here is matched to, on the other side of the bulkhead, this one here, and they are through bolted to each other through the bulkhead, and they are bolted as well to the upper plank. So that attaches the bulkhead to the upper plank. And now how about attaching the bulkhead to the diagonal plank? Back over to here. Attaching this panel to this panel is another angle piece here. And now you see there are various bolts going through the diagonal plank. Let's go on the other side, underside of the diagonal plank to see what that looks like. In here I don't have any plates, but I just have fender washers. And this, by the way, is well above the water line. The water line is way down here someplace. Now, there's one more part to the reinforcements in terms of Cusa board panels, and that's this one. Once the deck is on, this piece here will go and be just like those others, except that it will bond under the deck. So it'll be there, just like the other ones, but under the deck. And then there's one more thing, and that's that when the deck is on, these guys are in place, glass as well. There will be a component that will be fabricated like this. This will be made out of aluminum plate, fairly light gauge, like eighth inch at the most, maybe less, and it fits right here. It's bolted to the mount plate, it's bolted to the deck, and these are Cusa board inserts to show where the 5 bolts going through will be, and it's bolted to the bulkhead. Now, that explains the structure of the Oct mounts, but I want to give one final reinforcement of the fact that the Oct mounts are very important. All the forces on a boat are concentrated on the Oct mounts. If the Oct mounts break, you lose your stability of the boat. The main hull can't even stand upright without the Oct and the AMA in place. And so to anticipate these, how strong it had to be, I had a friend help me a lot. His name's Max Kissmartin. He's a aeronautical engineer, and he showed me the various things I had to look out for. He anticipated some of the places things could break in certain directions, and he was not able to help me with an actual penciled out forces, loads, and determinations of the thicknesses of scantlings of things. We were unable to get to that level. In my opinion, that's only possible to do for somebody who is not only an engineer, but an engineer with experience in the types of things you're building. So, but it was certainly useful for me to have him explain all these things. And it's been, as you can see, it's been a complicated set of things necessary to make these Oct mounts strong enough. And so now we're going to go back to the model. And I've made this model not just to show you the overall configuration, but to serve as a destruction test that I'm going to do right now. And that's that I'm going to break this. And let me explain that there are 3 main ways in which, actually, let's go to where the natural light's better, so I don't have to have this headlamp on. There are 3 main directions of forces. One of them is imagine that the ocean with its big waves is a monster holding this and trying to break it. So I'm holding this and I'm holding this and I'm trying to break it like this. That's one direction. Then there's this. And then there's this. So I'm going to do each of those motions sequentially and a little bit stronger each time until it breaks. Now, the Octas could break, or the Oct mounts could break. Now, again, the Oct mounts are represented by just little blobs of epoxy connecting the Octas to the deck. The deck, what represents the deck, is held firmly onto this wood by way of tacks, but the Octas are only held to the cardboard by means of these little blobs of epoxy. So here we go. I'm going to start trying to break it. So far so good that way. So far so good that way. So far so good that way. A little bit stronger. So far. Okay, there we go. So the first failure has actually been on the deck. So in this case, you might say that what failed was that the spreading of the loads, the reinforcement fanning out from the from the Oct mount didn't go far enough, because the Oct mount itself didn't break, but just outside of the Oct mount it broke. That's about all we need to do. Okay, so that's all I can do in terms of epoxy work. I might do some other work this winter, but good enough for now. See you guys later. Bye.